Welcome back to California State University, Northridge, the Department of Chemistry and Biochemistry. My name is Alex Machinota, and I will be your host for experiment number 9 of Chemistry 101 Lab. So today we're not going to go over too much technique. Most of it's a little self-explanatory. Once you're actually in the room, you're going to see what we're going to be doing. So I'm just going to give you a brief overview of some concepts you're going to need to know, as well as how you're going to go ahead and do the lab report. So the concept that we're going to be looking at is on atomic emission. So atomic emission is essentially if you excite something with enough energy, the right amount of energy. In this case, we're going to be exciting it with electricity. What you're going to do is you're going to excite electrons up into higher orbital levels. When they come back down, they're going to emit light. And since every single element is different, they are all going to have their own characteristic spectrum. So it's kind of like a fingerprint. All of us are human beings, but we're all different people. We have different fingerprints. Elements have different fingerprint spectrum. So we can use the spectrum to figure out what element it has. Now, in this case, we're going to be looking at two elements, hydrogen and helium, and we're also going to be looking at some conceptual theories that let us calculate out these wavelengths. Now, the first thing we're going to do is we're going to look at a helium lab. We're going to take our data from the helium lab, and it's going to be a set of distances that you actually measure out, and that'll be your y-axis. And we're going to compare them versus the wavelengths. And the wavelengths for helium can be found in your Chemistry 101 manual. So this guy right here, upside down, actually has the wavelengths. And you'll find that in your experiment number 9 section. So you're going to make a chart comparing your distances versus wavelengths. So your measured versus your controlled. After that, then you're going to measure your hydrogen wavelengths. And those hydrogen wavelengths, you are then going to take the distances that you measure and then plug them into the equation that you found for your helium. So your helium acts as your standard curve, and your hydrogen is going to be a set of values that you're going to plug into there. Now, you're going to take those values to figure out the wavelengths of hydrogen. And then you're going to compare them to the theoretical wavelengths that can be found using the Balmer-Rydberg equation. So that's essentially the breakdown of how you're going to be doing your lab. If you have any other questions, you can go ahead and talk to your instructor. You can wait for the pre-lab lecture, or of course email your instructor and just show up for class, and you'll have somewhat of an idea of what you're going to be doing. That is it for now. Thanks for joining us, and we'll catch you next time.